In this video, we're going to talk about describing a distribution, and specifically a distribution of quantitative data. So when we're asked to describe a distribution, we want to talk about the shape of the distribution, the best measure for the center of that distribution, and the best measure for the spread of the distribution. This is a big conversation, so I'm going to split this into two different videos. And on this first one, I'm just going to talk about the shape. So when we discuss the shape of a distribution, we look at three things. We talk about the skew or the symmetry of the shape. We talk about the modes of the shape, which are actually the number of peaks, not to be mixed up with the measure mode. And then we talk about the unusual features. When we talk about the center of a distribution, we have two measures for the center, the mean and the median, and we have three measures for the spread, the standard deviation, the interquartile range, and the range. So let's talk about shape. So looking at symmetry versus skewed, so we have three histograms here. The first one, the green one, is symmetric, and it's symmetric because if we were to put like a line down the middle, it would be approximately the same on both sides. Now I know that when you took an algebra class and you talked about symmetry, it was perfectly the same on both sides. It's not going to happen with observed data in statistics. In statistics, we kind of say it's close enough to say it's symmetric. It doesn't have to be perfect. So this green graph, it's very nice, and it's very close to being perfectly symmetric. But that's a good symmetric graph. The red graph has a tail. We call these like lower values here. This is the tail of the shape of the distribution, and this tail is going off to the right, to the larger values. And so we would say that this distribution is skewed to the right or positively skewed. The blue graph has a tail that's going to the lower values. So we would say that this is skewed to the left or negatively skewed. When we're looking at the modes, we're looking at the number of peaks that the shape of the distribution has. So in this first light blue graph, there is one peak. So we would say that it's unimodal. For the purple graph here, we have two peaks. So we would say that that's a bimodal graph. And then we're going to try to draw on the dark blue graph. There's a lot of peaks there, so we would say that that's multimodal. Now the graph on the bottom doesn't really have any peaks. Basically, all of the bars are going to approximately the same height. Again, it's not perfect, but it's approximately all the same height. So we would call this shape uniform. The last thing that we talk about when we talk about the shape of a distribution are any unusual features. And that's for the most part, means that we talk about outliers. Now, outliers are data values that are really far from the rest of the other data values. So they're either very far below or very far above the other data values. There's several reasons that an outlier can occur. It could be that there was some kind of mistake in the data collection. So for example, maybe you put out a survey and ask people to give their height in terms of inches, and somebody writes 6. Well, nobody's 6 inches tall. They probably are giving their height in feet, but you still have to enter the data as 6, but it was a mistake in the collection of that data. But that's not always the case with outliers. Imagine that we had a distribution of income and Jeff Bezos was in the data set. Well, his income is far, far above everybody else. It's not an error. It just is much further above everybody else's income. So you can't assume that an outlier is an error. And sometimes when you have outliers, they can be the most interesting part of a data set, and it can give you some important information. We will talk about how to actually calculate outliers when we look at box plots in Chapter 4. When we're looking at a histogram, you want to be careful not to assume that just because there's an empty bin that anything like right before it or right after it is automatically an outlier. Now, we do have it looks like several empty bins here, right? And then we have this bin here, which this should actually say outliers because it looks like there's about 3 of them in here. So I would say that this is most likely outliers, but you really don't know without making a calculation. So whenever I'm looking at a histogram and discussing outliers, I always use the term possible outliers. And then when we get into Chapter 4, we can actually calculate them and say for sure whether or not something is an outlier. All right, let's look at an example. So this came from the data set way back in video 1. It's the combined fuel efficiency in miles per gallon. So we've got a histogram here. If we look at the shape of this histogram, let's talk about whether or not it's skewed or symmetric. Well, we have this tail here going off to the right, so we would say that this is skewed to the right. There's one peak, so we would say it's unimodal. We don't have a way of calculating outliers, but we definitely have some values here that are further away from the rest of the other data values. These here could be outliers, but even this bin could be outliers. So I don't know for sure, so I'm just going to say that there's some possible outliers to the right.